All right. So this is what we are going to do today. It's called empirical formula. Now, the differences between the empirical formula of molecular compound versus ionic compound. Whatever you're going to experience, like have an experience, in other words, the experiment, this is a calculation. It is applicable 100% to the formula of that chemical. Remember what we did, what we learned so far. We were talking about the formula of each one of those chemicals, and then we mentioned something like when I put C6H12O6 and I said those numbers are by mass, you can have them as an identification for this chemical, right? We're going to use them to calculate the molar mass. Today we're going to work on the molar mass. When we are going to find out, we're going to calculate that. What is the X and Y, those subscripts. But instead of this one, which is a molecular compound, this is a sugar, this is a glucose, okay? We are going to have an ionic compound. This is ionic compound. Ionic compound made with the reaction of zinc with iodine, okay? Out of the reaction, we're going to mix them together, add a catalyst, which is the acetic acid. Then we're going to let the reaction go through, and then after reaction is done, we are going to measure the outcome, the whole entire compound that we made. The experiment equation is made with zinc reacted with iodine. This is what we are making. This is what we are expecting to make, okay? So we have zinc, iodine, to make zinc, how do we call it? How do we call that?
Zinc iodide.
Iodide with IDE. Okay, so that's what we are going to make. But we don't know exactly what is X and Y. In other words, this is what we are going to project, right? Expect. But sometimes with the, human errors, any transferable, when we transfer from one container to the other, we're going to have some errors. So sometimes this ratio might be different. If you are accurate with your experiment, maybe you're going to have the ratio of 1 to 2. That's what we want to, attain or obtain. All right? So this is basically what we are after today. All right. This is the theory of it. All right? Now, what we are going to do in the experiment, everybody should have a small beaker, and then a large beaker. The large beaker is going to be for the boiling. We're going to boil water. We're going to bring it into boiling. Be careful. You have to have your goggles. Stay away from the hot plate that you have there. And I set up this apparatus. So this is going to be the way that everybody should set up their own apparatus. The only one missing is the dish. You need dish for every single one. So we're going to put that one here later. Okay? So that's why I kept these rails and the clamp and the hot plate. All right, how are we going to make up? We're going to cook and make the compound. So you need to weigh 1.2 gram of zinc. So we have the zinc, powder zinc, okay? That's the powder of the zinc. It is it looks like gray or silver, right? Granule. We're going to weigh 1.2 grams. Put it in that beaker, the small beaker that you have. Okay? You have yours? Okay, there it is. And then you're going to weigh also 1.2 gram of the iodine. And then add it to the zinc. Then with the cylinder, do you have a cylinder? I'm going to get you the cylinder because we used it. You need 3 milliliter of acetic acid. Every single table should have the solution. This one, it said acetic acid 0.2 molarity. 0.2 molarity is the concentration of that acid. That's how we made it. Okay? So you're going to add 3 milliliter of 0.2 molarity acetic acid. And after you mix all those three, you're going to swirl it, like, just swirl it. Swirling meaning this. That's swirling, okay? And then wait for 20 minutes. Wait for the reaction to happen. You're going to feel, sometimes student was telling me, oh, it did not change, like in the temperature. Temperature will be raised because this type of reaction, when you mix them with the acid, it is an exothermic type of reaction. So it is going to produce heat, and you can feel it in the bottom of your beaker. Wait for 20 minutes, and then after that, after you finish 20 minutes, you're gonna see it's a dark, maybe brownish, mahogany, something like that, like color. You're going to decant it. Decanting means this is the dish, it's called evaporating dish, that you're going to put it on top of the other bigger beaker. And here we have the mixture of the two chemicals. You're going to decant it very slowly, very carefully. You don't want to have, because some of the solid is not going to work. It is not going to be reacting. We're going to have residual of the zinc here. The zinc, that color, that one. It's not going to react, all of it. Usually we're going to add extra of the zinc. We call it excess reagent. Have you heard about this in the calculation? Excess reagent, and the iodine is the limiting reagent. So we expect that the zinc is not all of it going to go into the reaction when it is going to be mixed with iodine, okay? After you do that, and after 20 minutes, you're going to take that, only the solution, not the solid. Some of the students, they actually transferred some of this solid into the dish, which is not correct because it's going to change the calculation. Anyway, so you're going to put it in here, all right? Whatever left, you are going to rinse it. You know what we mean by rinsing. 1 ml of the acetic acid. Rinse whatever left over of whatever, like, the leftover. Rinse it and then add it. 1 ml, and then another 1 ml, and then take that one, and you're going to put it on top of the hot water. You have to fill all these the large beaker with water, tap water, and then let it boil. We want to evaporate the whole entire solution from this mixture, okay? What you need from this one, whatever left over, you need to rinse it 3rd and 4th time. Remember, we had first 1 ml, we added to the dish, right? 2nd time, 2nd rinsing, added to the dish. 3rd time, when you rinse it, you're not going to add it to the dish. You can put it in somewhere, like, you can take it with that, very, very slowly, and then discard it under the hood. Just the solution. Don't touch the solid metal. And do this twice. You're going to do this twice. In other words, you are rinsing the leftover zinc twice with 2 ml of the same solution of acetic acid. This is the residual, and we need the residual. Why do we need the residual? If you go to page number 23, I want you to just flip into 23, please, of the handout that I gave you. So, you need to measure the mass of the beaker when it is empty. Empty and dry. That's number 1. You see, write the balanced equation. I think I write it down for you. This is the balanced equation.
Sorry.
Okay? So that's number 1. You see, it's mass. Number 2, the mass of the beaker. Number 3, mass of the evaporating dish. This has to be weighed as well, all right? When it is empty. Then mass of the iodine, we're gonna weigh 1.2 gram of zinc and 1.2 gram of the iodine. When you combine them, how many gram we have total? 2.4, right? So here it says mass of zinc plus iodine. Then it says, observe. So when we're gonna mix them together with the acetic acid, we're gonna observe, we're gonna see the changes, we're gonna wait 20 minutes. After that, we're gonna start decanting, right? The residual is the non-reacted, right? How are we going to find out how many of the zinc reacted? In other words, the mass of the zinc consumed. How do we find out about it?
From solid.
We weighed the original 1.2 gram zinc, right? Minus the residual. Yes? Or the consumed. It's the same. The residual or the leftover, that will give you the consumed. That's how we're going to measure the consumed. The original is 1.2. Residual is whatever left over in this beaker after you rinse it twice, right? Or 4 times, let's say. You have to make sure that it is going to be dried. Because if you have any of the solution of acetic acid, it is not going to weigh correctly. So usually what we do, because we have a hot plate, and you say, like, you've seen that, it says cracking. Cracking, just rub it like this on the hot plate. So that will take off any solution, any water that we have there, okay? Make sure that it is dry. After it is going to dry, you put it on, you put it on the bench. Make sure that it is going to be cooled down. Then you're going to weigh it. When you weigh it, it is the beaker plus the residual, right? You have to subtract the beaker weight. And that will give you the residual. Now, once we found the number of gram of residual subtracted from the 1.2, that will give me the consumed. That's what I need in grams. When we find the mole, which is the X, is equal gram of zinc consumed divided by the atomic mass, molar mass, which is the mass, the atomic mass unit of the zinc. What is it in the periodic table? 65.39 gram per mole. So divide gram by gram will give you the mole. That's the X of zinc. All right? How are we going to find the Y of iodine? So this is going to be the next step. We need to find the mass of the collected zinc iodide. After you finish rinsing whatever you have from the beaker, you have it here, put it on top of the hot water, and it is going to get dry, right? When it gets dry, you do cracking as well. Make sure there is no water anymore, no acetic acid. It is going to turn into off-white powder, should. That's how it's supposed to be. Make sure you put it on your bench, let it cool down, and then wait. Remove, subtract the weight of the dish. We don't want that. So when you finish that, we are going to be able to collect the zinc iodide, right? That's the collected zinc iodide out of the reaction. When we subtract the mass of the consumed zinc, that will give me the mass of the zinc consumed, right? That's how much? Because I have zinc iodide minus zinc will give me the iodide. So once you found the mass of the iodide, divided by the molar mass of the iodide, which is 126, that will give me the mole of the iodine, and that's how we find the zinc and the iodine. This is the X and Y. So this is the actual, mathematical and the practical. Do you have a question? Now, where are we going to find whatever I talked about? Okay, so you go into page number 17, the procedure for part A. Follow the procedure. Whatever I was talking to you about, probably, I'm sure, if you did not read it, you're not going to recall what I just said, right? So please read that. It's actually giving you exactly step by step. I put it in here for you. You have all the chemicals. Look at the chemicals, it's already there. And you need a spatula. I'm going to give you the spatula. There is another thing that you need. Oh, the cylinder, because you want to weigh the 3 milliliter. And then after that, mix them together with the 3 milliliter after you weigh them. All right, make sure that you tar it. Tar the balances before you weigh, okay? And then add the chemical. You're going to have the total chemical plus the container, whether it's beaker, whether it is dish. And then you subtract the container. That's how you're going to get the number of gram or milligram of the chemicals itself, okay? So just bear me a couple minutes. I'm going to give you the dish for everybody. And then, if some of you have the spatula, this is what you're going to weigh with. And you have 2 of them. You see, every single table should have 2. One for the zinc, one for the iodine. Okay? Now, the heating is going to take about an hour. You have to adjust your timing, yes. An hour. For the acetic acid solution to be evaporated, yes. It's going to take some time. So, and then you have to also adjust your clock on 20 minutes after you mix them together, the chemicals. So we have three balance here, and we have the zinc. I put the zinc and the iodine for you here. You can bring your own spatula and weigh with. And be careful, you don't want to mix both the 2 of them together. You need to have that so you clean. After you weigh the zinc clean and then weigh the iodine. By the way, iodine is going to be reacting with aluminum. Be careful. It's also irritating. Don't try it. I'm sure we all have that and mass. But what I would recommend, bring your beaker. Bring your beaker with you and bring it over here. The minute you weigh these chemicals, put them in the beaker. Because the iodine is going to react with the aluminum. And the weighing dish are aluminum. Okay? So everybody got the dish? You have everything. You can start. Make sure you wear your goggles, please, when you weigh over here, because you need to be careful with the water. And anything more than 3, don't throw it away in the sink. We have it under the hood. You throw it in those like funnel with the Erlenmeyer flask.
3 milliliters of oil. Yeah, and then we have the 3 milliliters.
The pipette? Professor, are we allowed to use the pipettes for
Right here, you gotta measure 3 milliliters. No. Doesn't say it on here. We have to do it. This is not silver.
Should I ask her? How do we measure
Page number 17 will give you step by step whatever we were talking about the procedure, okay?
Oh, that's what it was. The lab place, I mean, obviously, everything. I mean, but it's something.
Oh, excuse me, excuse me. How many of you were able to measure the residuals so far? So, group one, how about yours? What was it? 0.9. So group one here was 1.1, yours 0.9, almost the same. There is, I think, 1.2 or 1.1 as well. So we are good. We're good so far, right? The zinc iodide. We need to have the zinc iodide over there. We have to subtract it from the consumed zinc. That will give me the number of gram of the iodide consumed. And then after that, this is the consumed zinc divided by the mass of the zinc, which is 65.39. This is the atomic mass of zinc. That will give me the number of moles of zinc, which is the substance of the formula. And then also we are going to calculate the consumed iodide by subtracting the consumed zinc from the collected zinc iodide. That will give me the number of gram of the iodine reacted or consumed, divided by the molar mass of the iodine, 126. And this is going to give me the number of moles of the iodine. This is exactly what we are after. We want to find the smaller, the X and the Y. So the X is the number of moles of the zinc reacted, and the Y is the number of moles of iodine reacted.